morning. The last classes we have learned about internal energy, enthalpy, and the different properties of enthalpy and its comparison with internal energy function, etc. Today we can learn about the next thermodynamic potential, that is Helmholtz free energy. Helmholtz free energy, represented by A, PV. The Helmholtz function is given by the equation A is equal to U minus Ts. The infinitesimal reversible process, we have also written the equation, that is dA is equal to minus PdV minus SdT. We have already derived this equation too. So this is the infinitesimal reversible process. What is the Helmholtz function? This dA is given by minus PdV minus SdT. First, for a reversible isothermal process, what is isothermal? This temperature is a constant, so dA can be rewritten as minus PdV. So what is the total change? The total change when the function is going from, or when the process occurs from an initial state I to a final state F. Then this change can be written as the total change after integration. We have to integrate. Then the total change when the system is going from an initial state to final state, dA is equal to minus integral I to F PdV. So this is some A final minus A, this is for constant at constant temperature process. So A final minus A initial at constant T is equal to minus integral I to F PdV. So what is this minus integral I to F PdV? This is actually the work done during the process. Actually the work done here is isothermal, so Wt. So the change in Helmholtz, or the total change in Helmholtz function during an isothermal process, during a reversible isothermal process, is given by minus integral PdV, which is actually the work done during the process. So if the Helmholtz energy or if the Helmholtz function is increasing, means this will be a positive value. AF minus AI should be a positive value. So we should get this total value, that is minus integral PdV, a positive value. That is, the work should be a positive work. When will the work become a positive work? If the work is done on the system, the work is a positive work. So if Helmholtz energy, if Helmholtz function is increasing, that means the work is done on the system. If the change is, that is A minus AI is positive, or if Helmholtz function is increasing, we can say that the work is done, then the work is done on the system. That means if work is done on the system, its volume will decrease. So we will get I to F, means we will get a negative volume, change in volume is negative. positive work, that is work is done on system. Then if the Helmholtz energy is decreasing, that is if AF minus AI is negative, that is Helmholtz function is decreasing, then you should get a negative value this side. That means the volume is increasing, that is the work is done by the system. The work is negative, we will get the work as a negative quantity when the work is done by the system. Then we can say that then the work is done by the system. This is on the system. So then the work is done by the system. So there are two different types. This Helmholtz changing Helmholtz function, that is directly depending on the work done during the system. Similarly, the enthalpy is actually given by the heat, different heat, latent heat, etc. You have already learned in the last class. Like that here, the Helmholtz function is given by the total work done during the process. Actually, Helmholtz function, thermodynamic potential, it is also called Helmholtz free energy. For a finite isothermal process, this equation can be rewritten as some delta A is equal to delta U minus T into delta S. That is, this is for isothermal process, delta S at T. So what is this T into delta S? Actually we can write it as delta U T minus, this is T into some delta S, that is delta Q at a constant temperature. This is actually the finite work. This is from first law. This is from first law. So delta A T is equal to delta U T, that is constant temperature only, minus delta Q T equal to delta W T. So if this Helmholtz, if work is done by the system, its internal energy will decrease. But this decrease is not exactly equal to the work done. So we can write three conditions here, that is delta WT can be greater, equal to or less than delta UT, depending whether QT, delta QT is positive or equal to or less than 0. That means WT is greater than WUT, that is the change in internal energy or the small value of internal energy. So when this quantity is greater than delta UT, this is greater than delta UT means you will get plus sign, total plus sign here. That means delta QT should be a negative value. If we will get WT greater than delta UT when delta QT is less than 0. This less than 0 means this quantity is negative, negative into negative positive. So the total is greater than this delta U. So work done is greater than delta U. If this quantity is equal to 0 means this is equal to 0, then W will be equal to UT. If QT is less than greater than 0, if QT is greater than 0 means this is a positive quantity, so the total change this minus this, then WT is less than WUT. So from this equation we can write again, for a reversible isothermal isochoric process, isochloric process. Isothermal means constant volume. So isothermal means constant temperature. So for a reversible isothermal isochoric process, dA should be equal to 0 or A is a constant. That is, there is no change in the Helmholtz function in an isothermal isochoric process. So from this equation, we can write the partial derivative here, dou A by dou V at a constant T. Dou A by dou V at a constant T means isothermal process, this will goes to 0. So dou A by dou V at a constant T equal to minus P. This is minus P only. Then similarly, dou A by dou T at a constant volume. At a constant volume, this value will equal to 0 or will goes to 0. Then dou A by dou T at a constant V equal to minus S. That is, this function is actually depending on V and T. It will also depending upon other thermodynamic variable that we can write later. The equation, there may be different equations for this gives free energy, but this partial change can be written as minus P and this partial change can be written as minus S. That's all about Helmholtz